Liquid Based Cytology, also known as LBC. This is a modern method used in laboratory medicine to improve the way we collect and examine cells. Problems with conventional cytology. Conventional cytology, or the older Pap smear method, has several weaknesses. Sometimes cells are not collected properly, or they don't get transferred to the slide at all. Even when they are, they might be poorly preserved or hidden under mucus or blood. Then, during screening, errors can happen. Abnormal cells might be present but overlooked, or they could be misclassified. In short, both the collection step and the interpretation step can fail, and that reduces the reliability of conventional cytology. In the traditional method, cells are smeared directly onto a glass slide. That may sound simple, but the problem is the cells can be clumped together, damaged, or spread unevenly. The image shown here illustrates how this direct smearing can make it difficult to see everything clearly, which increases the risk of missing important changes. Notice in this example that precancerous cells, marked in red, are present in the sample, but the sample does not always represent the true condition of the patient. That means a doctor might miss early signs of disease simply because the collection method failed to capture the right cells. This is a serious limitation of the older smear technique. What is liquid-based cytology? Liquid-based cytology is a newer approach designed to solve those issues. Instead of smearing cells directly onto a slide, the collected material is placed into a vial of liquid. From there, a special process prepares a cleaner, more uniform sample for examination. This improves both accuracy and visibility. There are many benefits to using LBC. Because the cells are fixed immediately in liquid, both the nucleus and cytoplasm look much clearer. All the material that was collected can be examined, and more than one slide can be prepared if needed. The background looks cleaner, so important epithelial cells are easier to spot. Cells are spread evenly in a thin layer, which makes screening faster and reduces the chance of missing something. Unsatisfactory samples become much less common. On top of that, the same sample can also be tested for viruses like HPV, and LBC slides can even be read by automated machines. Altogether, it makes the process more reliable and efficient. Of course, LBC is not perfect. Because the cells are randomized, the traditional smear pattern is lost, and abnormal cells may be scattered across the slide. If only a few cells are present, interpretation becomes harder. Elements such as blood and mucus are still visible, though they may look slightly different than in conventional smears. Epithelial cells often appear as single, smaller cells, especially certain types like endocervical or immature metaplastic cells. And importantly, this method is more expensive than the traditional test. LBC is not just a theory, it is a regulated system. It has FDA approval, it produces standardized and reproducible results, and multiple studies have confirmed its ability to recover cells efficiently. There are two main systems widely in use, and while alternatives exist, they must undergo equally thorough testing before they can be accepted. Some might ask, why not just use cytospin? Cytospin is a technique that concentrates cells from a fluid onto a slide. It works well when dealing with samples that contain very few cells, like some lung fluids. However, it is not suitable when there are many more normal cells than abnormal ones, because the abnormal ones get lost. It is therefore not appropriate for LBC. For example, in bronchoscopy samples, cytospin can be used to study interstitial lung disease, but if the goal is to detect cancer, another method such as millipore filtration is required. There are two main commercial systems for LBC. The first is ThinPrep, which uses a filtration method. Cells pass through a filter and then stick to a coated slide. The second is SurePath, which relies on centrifugation. Cells are spun and allowed to settle onto the slide. Both systems are designed to produce clear, uniform samples, and both are linked with automated screening and HPV testing technology. Finally, we take a closer look at the ThinPrep system. This method filters the cells and creates a thin, even layer on the slide, making examination faster and more reliable. By standardizing the way samples are prepared, ThinPrep reduces the chance of errors and ensures that abnormal cells, if present, can be seen more clearly.